Yeah. So now this problem gets very tough. We are still going to think about a solution for this. Minus 3 0. I don't think it only has 0. It denotes less than or equals to the real number r for all the numbers. Oh, it's different in negative. So the problem here, I calculate this wrong. This should be -1. So therefore we have the chance of 0 and -1. And we are done. Problem 9. Let's try problem 10 with problem 10. Okay. In a given plane, point A and B are 10 units apart. How many points are there so that such the perimeter of ABC is 150 units and the breadth is going to be 150. So there is like C. So we want the base is 10 and height is 10. Right, so we assume AB is the base. So we know that base is 10, height is 10. Right? So what we are going to do next, and we want the perimeter to be this. So it just depends on which point we do it. There must be one point that satisfies this equation. So this is 1. After we rotate it, it's going to be 2. So I think this problem is going to be so this, and there's the opposite way of doing it. So there's going to be 4 ways in all. Yes. No, there's still a way of rotation, so it's D. Right? So in this case, it might be that in D, but we still need to try whether there is a dot that fits this equation. So which makes this 10 square, and we set this as x and this as 10 minus x, right? And what we are going to do next is we are going to let 10 square plus x square 10 minus x square plus x plus 10 square. So we want to know whether this has the result or not. Is equals to 40. So we want to get this equation out. Plus x the pin. Yes, so it's 40. 200 plus x squared minus 20x plus 100 plus x squared is equals to 40. So this now shows the problem, whether we are able to solve it or not. It gets tough. If this has a solution, then we are able to get it. But if this doesn't, 400. How am I able to solve it? It gets a problem. Wait, shouldn't the height be 20? Wait, height should be 20. I make a calculation mistake. Height should be 20 here. So it's 400 plus x. Then it becomes 400, 800 plus x squared minus 40x. So let's calculate the range of it. The range of x. X should be... No, calculating range also does not help anything. Okay. Let's skip this problem first because I can't solve this right now. Let's do problem 11. Okay, this problem. 2 jars each contain the same number of marbles and every marble is either blue and green. In jar 1, the ratio of blue to green marble is 9:1 and the ratio of the blue to green marbles is 8:1. There are 9 each contain the same number of marbles. Okay. If there are 95 green marbles in all, how many? Okay. 2 jars each contain the same number of marbles. Each marble is either 901 to 821. So it's like it requires you to for the more blue marbles in. So we can go start from the green marble. The ratio blue to green. Okay. So okay. X is equals to 450. After we know that this is 450 marbles in each jar, we know that the blue marble in jar 1 is 14.5. So the difference between jar 1 and jar 2 is 45. D. Let's now do problem 12. Problem 12. What is the greatest possible sum in the digit in base 7 representation of a positive integer less than 2019? Sum of the digit. Sum of the digits. Okay, base 7, right? How do we convert base 10 to base 7? Yes, it's like this. 7 times. Base 7 representation is in 0 to 6. So we know that this case is going to be as far as great as possible, right? This has one case, like this is going to be the greatest case. So we are going to try whether in series representation it is not, whether it is not whether it is a representation or not. I mean, whether it is less than 2019 or not. It is 49, 343 times 6. 49 times 6, 42. 240 plus 294. This is 180 plus 258. Right? Oh, this should be 0. It should be calculated in this way for the binary. So it is 343 times 6. It's going to be 20 or 58. This is going to be 49 times 6 is 240 plus 54, 294. This is going to be 42. This is going to be 6. So I think if this drops, then it is definitely okay. So it's 5 plus 6 plus 6 plus 6. Nope. There's 5 plus 6 plus 6 plus 6 is equals to 22. So it is C. What is the sum of all the real numbers x with all the medians, with which the median number is equal to mean of these 5 numbers? Okay. What is the sum of all real numbers x? Consider if 8 is median. If 8 is median, right? So which means x is yes, if 8 is median. So the left side does not change. So this means that plus 17 plus x divided by 5 is equals to 8, which in this case, x is equals to 5. If 6 is median, then if 6 is median, then x is equals to 4 plus 8 plus 17 plus x divided by 5 plus 6 is going to be 6, where 35 plus x divided by 5 is going to be 6. Where in this case, 35 plus x is going to be 30 and x should be negative 5. Yes. X is going to be negative 5 in this case. And what if x is median? So it's 35 plus x divided by 5 is x. 5x is equals to 35 plus x. So x is equal, 4x is going to be equals to 35. So x is equals to 35 divided by 4. So now we check these cases again. So we first, let's see the each cases x is equals to 5. It is not valid because in this case the median is going to be 6. This is going to be valid. And what's the case again, which is 35 divided by 4, which this is equals to equivalent to 8.75, and it is not the median after all. So it means it's B. It's 0. Yes, B. AMC is hard. Next problem. The base 10 representation for 19 factorial is 12165 10040 A32 H00. Wow, what the heck? What is the base the note digits are not given, so it requires us to find the T plus M plus H. This is definitely going to be 0 because there are 3 which are going to cost 0. So we know that H is going to be 0. But how are we able to find M and the T is hard? Yes, how are we able to find them? Should we calculate them? Nope. The base 10 is okay. Okay, we can just use hard calculation to do it. Since I currently don't have an idea of solving this. 7 factorial. 8 factorial times 8 is 2, 3, 3, 4, 0, 3, 2, 0. 9 factorial. 8, 1, 8, 2, 2, 3, 8. 38280. 9 factorial is 382880. 10 factorial is 3828800. 11 factorial is 3828000 plus 3828800. 0086112 3828800 plus 3828800 0086112 48116800 times 12 is going to be, oh my god, I'm going to skip this problem. I'm going to skip 14 now. Let's try 15. Right triangle out T1 and T2, a side of, okay, the different side is congruous. Okay, I hate geometric problem. Let's do 16 instead. A, B, C. Oh my god, there are 2 8. Okay, 17. This redirects. Okay. A red ball and a green ball are randomly and independently tossed into bins numbered with positive integers over each ball. The possibility of the toss getting to is let's say the possibility that red ball is tossed with a higher numbered bin than the green ball. What does it mean? Are randomly and independently tossed into bins number. The red ball and green ball are randomly and independently tossed into bins numbered with positive integer. Oh, I mean what it means. I know what it means. It follows the geometric series, right? So it's like this. Possible for K is this. ARN minus 1. So it is a geometric theory as red ball is tossed into a higher numbered bin than green ball. Okay, red is tossed into higher numbered bin for green ball. 2, 1, 3, 2, 1, 4, 3, 2, 1, 6, 6, 2, 1. So he has 1/4 of the theory tossed into the second ball. So, and it has the 1-2 theory. If he tosses in the third ball, red tossing the third ball, the red ball is tossed into a higher number being than the great ball. So which means this is going to have a chance for 1-2 plus 1-6. If he threw in the third ball, which is 1-16, then he's going to time 1-2, 1-4, 1-8. Let's see a geometric theory. 1/8乘以4/3。So it should follow a geometry. It should follow a rule, like for every term. Like every term should be calculated like this. Times 1 minus it has a geometric theory like this. So the theory is like this. What is the possibility that it's goes into a higher ball being than the green ball? Then let's try to find the limit for this. Okay. So it's like this, you see? So which is so it's like this. It has a formula for it actually. R divided by the limit for this. Minus 1 R divided by E divided by R. Okay, A divided by 1 minus R. A divided by 1 minus R. So let's try to form it in the shape of this. How? I'm trying to find the limit for it, but it does seem like it doesn't work. Okay. A is 1, right? sigma notation. Okay. It is not a geometric theory. Okay, we can just, so what we now can do is we only can try attempt a result. So it's like this. So we try a result 1, 8. See what it converges to. Plus times 3/4, which is 332. Plus 7, 128. Every time the sum of this is going to be this. We set it as the first term. And then it's right. 2 and minus 1. It actually has a rule like. It should be look like this. So it's like this in the notation in this case. But the problem is I can't convert it into a theory. Maybe I can do this. Minus 1. So I want to make it into a geometric form. So we put it in the case of this. So it now forms a strong geometric shape. So let's calculate the infinite case of this. So A is this, right? 1 minus R. R is then we make this as infinite. Let me think about this problem. Now it gets harsh. So it's A, right? Okay, I still don't have a great way of keeping to this. Okay, let's continue trying. So it's 4, 12. 16 plus 12 plus 7 is 35. Let's see what it directly converges to. According to the sigma, it's 2, 3, 2, 5, 2, 7, then it's 2, 9, 5, 1, 2. This is going to be This is going to be 5, 1, 2, 2, 2, 2 minus 1, 2, 4 minus 1. It's 15, so it's 5. Okay. I think there's a possibility that it slowly converges, so it's 40. I think there's a small possibility that it directly converges to this, right? It is converges to this so that it will be making more sense, like after we have attempted a few terms. So, but I'm not sure. I'm just going to choose C. Next. So hard. Oh my god, I've done 17. Now let's do the next problem. It's 18. AMC so hard. Let S be the set of all positive divisors of how many numbers are the product of two distinct elements of S? Let S be the set of all how many numbers are the product. Okay, I know. Now let's try problem 19. So it is asking us about how many numbers are the product of two distinct elements of S, while S are the set of all positive integers of something. Yes. Let me think. It's equals to 2 times 5 to the power of 5, which is 2, 5 times 5, 5, right? So in this case, it is going to be how many numbers of this? Sets of all the possible distinct elements. Oh. 2, 2, 5, 5, 5, 5, 5. Try recursion, like F1000. Time 2. No. 2, 5, 2, 5, 5, 2, 5, 5, 5, 2, 5, 5, 5, 5. 25 basic cases. So what are the interaction with 2? I think the breakpoint shows here. 2. What are the interaction? Yes, the interaction is only 1. No, it's choosing one distinct element. Okay. Distinct elements of 50,000. Distinct. Okay, 36. Okay, I'm going to skip this problem. Skip 19. I don't have any ideas regarding this one. 20. No, 21. She sees the second tail before she sees the second head. So we want to get this problem. Tail. Oh, so it must be that he stops in this case. Head. Okay, I still have 15 minutes left. I feel like I'm stuck on this. Okay, let's jump to problem 22. A O B. A B. Back to problem 19. I only have a few minutes left. The rest of the problems are all considered answered. Nope. Well, I only have a few minutes left now. I have less than 1 minute left. Define a sequence recursively by x0. Wow, it's hard. Right. X plus 1, x plus 4, x plus 6. I can try problem 24, a recursive problem. Like this. So it's like this plus 5x, xn plus 1, xn plus 4, xn plus 6. Okay. Time is up. I'm done. I need to check. So let me check. Let us check the answer. Problem 1. Answer D910. I think I get it right. Problem 2. I'm right. Problem 3. I'm right. Problem 4. I am right. Problem 5. I choose what? I choose C. I choose C. Okay. I'm wrong at problem 5. Problem 6. I'm right. Wait, am I at? Okay, though I don't want to. Problem 6. I'm right. Problem 7. I am right. Problem 8. I'm right. Problem 9. I am right. Problem 10. I am... No, I haven't figured out this problem. I'm choosing between 0 and 8, but I haven't get a solution, so it considers I'm not answering. 11, I am right. 12, I am right. 13, I am right. 14, I am... No, I haven't answered this. 15, haven't answered. I think I have answered 17. Yes, I have answered 17. 17. And 19, problem 19, I don't know. No, my last problem, problem 17. So I answered 15 problem. And I answered 14 problems. And I haven't answered the rest of the 11 problems. Of the problem I haven't answered, it was 2 marks. 13 correct, 13 plus 1. So my final mark is going to be 13 times 6 plus 2 times 11 plus 0, which is 78 plus 22 is 100. Conclusion. This test is extremely hard, like, compared to MC8. Like, I remember, like, I just don't feel any tired, but after I do this year's exam, I just feel, gosh, I need to sleep, rest, completely rest. Okay, so these are the ends of attempting the AMC 10, and see you next week. Bye.